This video is to show the mechanism for the Stork enamine reaction, starting with the enamine already formed. The enamine is a nucleophile and it attacks at the beta position of the alpha-beta unsaturated ketone. So essentially it's doing like a Michael reaction. That gives us a new carbon-carbon bond between the alpha position on what used to be the carbonyl and the beta position on what used to be the enone. So here's the new bond in red. Notice this intermediate has some charges on it. We'll work this intermediate up in aqueous acid, and that will neutralize the negative charge and hydrolyze the iminium ion. I'm going to neutralize the negative charge first. By protonating the enolate. So now the only charge we have is the positive charge on the iminium ion. The hydrolysis of the iminium ion is going to take 5 steps. I'm not sure I have enough space for it here, so I will redraw the iminium ion at the top of the screen and start over. So our solvent here is water. Water is a good nucleophile, so it attacks the carbon of the iminium ion. And gives us a tetrahedral intermediate. Since the nucleophile was a neutral water molecule, it still has a positive charge on the oxygen because the oxygen's got 3 bonds instead of 2. So the next step is deprotonation. This happens with some base that's in solution. It's not that we're adding hydroxide. So now our tetrahedral intermediate is neutral. Next, the nitrogen on the amine will be protonated. That turns it into a better leaving group. So the next step that happens is the neutral amine leaves. And there's one final step to give us the final product. That is a deprotonation step. We pull off this proton, the electrons from the OH bond help to reform the carbonyl, and we have a 1,5-dicarbonyl as the product of our Stork enamine reaction after the hydrolysis.